Fantastic. Okay, so I am a huge believer in having slides available to click to all the things. So if you are interested in following along, or you want to reference some of this content after the fact, you will find the slides at bit.ly/DL-telenovela. So deep learning-telenovela, pretty intuitive. But let's go ahead and get into it. Escuincla babosa, a Python deep learning telenovela. Before we do get into the core of today's chat, I did actually want to make a subtle call out, or maybe an intentional call out. Specifically, us as technologists, it is our duty to stay informed. This means educating ourselves on bias in tech, as well as how tech impacts and amplifies issues of equity. The decisions we make in how we build and use tech can have a real negative or positive impact. One thing I've done to kind of think about this is I've started a reading list that covers some of these topics, and I would be very open to your suggestions or feedback. In the link for the slides, you can actually go and check out a GitHub repository that I've started crowdsourcing, which maps to the website bias_in_tech. But more so than that, educating ourselves is good, but we can't stop there. It's not enough. We must engage and we must continue the work. So I would encourage you all to look at places around you. Maybe you're not in Chicago and you want to be involved. There's definitely other places to look. But here's some resources that do have a little bit more of a focus on the Chicagoland area. First, Black Lives Matter, talking about the What Matters 2020 campaign, which has a very detailed kind of set of agenda items that I think are very good to review and are very actionable for people to participate in. The Chicago Alliance Against Racial and Political Repression talks about some of the hyperlocal issues here in Chicago. And then actually, I have kickstarted a Bias in Tech channel on the Chicago Python user group Slack, which I think would be a great place for us to continue to talk about these themes. And then lastly, the Algorithmic Justice League is a really, really cool group that is doing some very important work about understanding bias and equity in tech. And I actually will give them a little bit of a head nod. So all that to say, I encourage you all to stay engaged in the conversation and continue to show up to do the work. And we all learn better by being invested in this together. So I hope that you all take advantage of some of these resources. So now getting a little bit into the talk. So you heard a little bit about my introduction, but just suffice it to say that my background, how I kind of got into being an engineer that I am today, which I work as a data engineer at GitHub. I come from this background of political science. So having more kind of like the toy problems that helped me do the work that I was very passionate about, be it when I was working on a presidential campaign or in grad school for research that I was doing, I always kind of had a little bit of a, I want to try to do that thing. And yet you're going to see that theme pop up in today's talk. So yes, again, my name is Lorena Mesa, and I am here because I am really interested in deep learning and wanted to start thinking about how I could understand deep learning more, because actually in my day job at GitHub, deep learning is a huge part of what our machine learning teams work with, and that is actually an area that I do not have as much expertise in. So I'm thinking about a way that I could learn about deep learning, and then also realizing that I really love telenovelas. I was like, let's see if I can marry these two topics together and come up with a talk. Win-win, right? I think so. By the way, I did mention I'll be tweeting things out. If you do want to stay in touch, that is my Twitter handle. And yes, that is Lorena with 4 O's in a row and then a 5th one at the end. But I'll have all the slides there posted. So let's go ahead and then actually talk a little bit about what is deep learning. And better yet, where have we seen it in the world around us? So one place that we may have seen it is in these real-time, looks like that bounced, let me get that back, is in real-time behavior analysis systems. So let's just take a moment for this. So as you can see, what this video is demonstrating is a technology called Deep Glint, which uses deep learning to derive insights on behaviors from people, on objects like people, on objects like cars. As you can see in this first clip here, what the system is providing insight is not only just observing what's happening in the bank, but also understanding the movement of the individuals. You'll notice that it's got an orientation axis showing which ways folks are engaging, which ways they're moving. And coming up in just a few seconds, then we'll see an example of Deep Glint and how it does real-time analysis of traffic. So so this next sequence here, we see that it's capturing some stats on motorists, both in cars and motorcycles. So this is one example of implementation of deep learning in the wild. Another place that we may have seen deep learning is this topic called deep fakes. So I'm going to actually pause here and play just a few seconds. The audio is not as important as much as it is that I'll be making some call outs. So we'll try to give this a go and see if that works well. So let's go ahead and check this out.
Meet Jennifer Lawrence-Semi, a deep fake mashup of actor Steve Buscemi and actress Jennifer Lawrence. This deep fake video portrait uses Buscemi's face on Lawrence's body, along with her facial expressions.
I've never looked better.
Scarily realistic deep video portraits like this could take fake news to the next level.
So I think that's also a really highly topical thing. Deep fakes, fake news, all things that are really being ripped from the headlines. So this YouTube series, Digital Trends, what they were talking about is specifically in 2019, that mashup with Steve Buscemi and Jennifer Lawrence was just an example of like what deep fakes are. So while Buscemi jokes he jokes on late night television that I have never looked better. What deepfakes are just one of the latest ways that today's society is being challenged by the increasing rate at which technology can invade our privacy or even warp our perception of what is truth in the world around us. Another highly topical and top of funnel example of where we may see deep learning has been quite literally ripped from the headlines in talking about facial recognition software. So moving left to right, what these are all kind of capturing. What we see on the left-hand side here is ripped from 2018, talking about the Amazon tech product recognition, which in 2018, the ACLU explicitly was calling out this piece of tech when it found that the Amazon product falsely identified 25 members of Congress as people who have been arrested for crimes. Additionally, the ACLU found that this software was using basically it's a data set, which is mugshots, about 25,000 images in a mugshot photo, where we have disproportionately imbalanced data, where we have more representation of BIPOC, that is Black, Indigenous, people of color faces. And also there has been a lot of question about just about the quality of mugshots themselves, you know, the way that different faces are captured. Is the lighting good? Is the lighting poor? All of these things are being used and then fed with deep learning to help actually do facial recognition. So while there's even some questions about how deep learning is used in that software, what got more problematic is then when it's being used in law enforcement. So as we've seen over the last week or two, we've seen big tech stepping up and saying that they will not be participating in selling facial recognition software to law enforcement agencies, with some saying, nope, we're just not going to do it, with others like Amazon saying, you know what, we're going to hold off for a year and wait to see if there's going to be some legislation that steps up to help us understand that. And as I mentioned, the Algorithmic Justice League as a potential resource to learn more about this, the Algorithmic Justice League founder, Joy, actually is someone whose research really began exploring the limitations of what facial recognition tech can do, particularly in identifying BIPOC faces. Her work was actually quite seminal in helping lead the discussion about the use of facial recognition technology. And if you're interested in learning about more of her work, she's prominently featured in a new documentary called Coded Bias, which is a part of the Human Rights Campaign Film Fest, which is available to view online. So deep learning, you know, we can use it for real-time traffic analysis. We can use it for surveillance technology such as facial recognition. However, we have other applications of deep learning in the world around us. For example, doing translation in real time. As you can see in the images here, in using Google Translate on my mobile phone, you're actually able to translate images from multiple languages. So in my example, what I was looking at my slide deck. What you see is that I've actually said the language is in English and I want to translate it into Portuguese. And the way that this is working under the hood is that there's a neural network that's used to read the image with an optical character recognition, an area of research in computer vision, which basically takes the text, translates it into characters, translates it, and then translates it back, superimposing it back into an image on top with the translation. So as you can see from these two examples, this is a little bit of a sensitive kind of implementation. So kind of like how you hold the image. If let's say you're taking let's say you're translating something that's on a piece of paper, if you're holding it a little bit of a different way, how that OCR, that optical character recognition maps, may be better, maybe worse, but this is yet another example of deep learning in the wild. And so continuing down this path, moving from computer vision of actually working on faces as an example, or generating fake faces, to now actually starting to look at text and text data. Another way that we may see deep learning in the world around us has been in the problem space of text generation. So ripped again from social media itself, because social media is rife with very interesting conversations about tech and what tech can and cannot do. We have this example here from March 2018, where there's a user on Twitter proclaiming, "I forced a bot to watch 1,000+ hours of the Saw movie and then made it write its own script. Here's the first page." This idea of being able to use deep learning to creatively produce text, that is creatively create a script, is something that is highly suspect by some folks. Particularly some folks were skeptical about the text generated from this alleged bot that had to watch 1,000+ hours of Saw, because there was words like Trump or whale that appeared in its script. And in fact, as far as I can understand, the word Trump nor the word whale actually appear at all in the Saw series. I'm not sure if it was just the first Saw or like all of the Saw films. And I will say I did not fact check that, because personally I don't feel like watching all the Saw movies for 1,000+ hours to see if those things pop up. It seems like a very strange combination. But the skepticism about how you actually do text generation with deep learning, and in the idea of trying to do something creative, like not just doing text generation, such as predict what words someone's going to enter into a search engine, but trying to do something in the more kind of creative realm, such as producing a script. There's a lot of questions about how possible that can or cannot exist with deep learning instrumentation. A rather interesting example that I came across was actually not the Saw did the whale not do it debate, which as you see on this previous slide was actually a meme that people were using, trying to call out that, you know, it was interesting how this word whale materialized in the script. But actually was other folks are thinking about how to do creative computation with deep learning to create things that we presume that only humans can do, such as create art, create films, all of these things. One example of someone thinking about this is an individual by the name of Ross Goodwin, who in 2017 created this short, which Ars Technica captured, alleging that it was perhaps the first work that actually used deep learning to actually create and generate a short film script. I am not going to play that film for you. It is quite intriguing. It's a little bit of a short. I would encourage you to go check it out. Again, this does link to that short. If you do want to watch it, yes, it does involve David Hasselhoff, but there are other people trying to think about how can we stretch the applications of what deep learning can and cannot do. And here's just but one example where, yes, we do get a short with David Hasselhoff. So returning to the idea of, you know, where is deep learning around us? How is it being applied? It's being applied in a lot of interesting ways that we may not understand or at face value think it's possible. So in thinking about, you know, what's a toy project that I could try out, I thought, okay, well, let's go ahead and let's try again this idea of text generation. But, you know, instead of making a short with David Hasselhoff or doing something inspired by the Saw, because I'm not a huge fan of horror movies, I thought, well, what would it look like if we were to use deep learning to try to create a telenovela? But in order to even do that, I think it probably is important for us to actually talk about what a telenovela is. So to help us think about what deep learning can do, can it create a telenovela? Let me pause and give you a little crash course on telenovelas. So I'm going to start with perhaps an explanation of one of the most absurd things I've ever seen in film, let alone perhaps on television. And that is the legendary Escuincla la babosa, which is lovingly featured in the title of this talk. Escuincla la babosa, roughly translated, means you spoiled, stupid, entitled brat. Emphasis on the idea that we have a child that is somehow entitled, and that is supposed to be a term shaming that child. So the legendary Escuincla la babosa scene comes to us from a telenovela named Maria la del Barrio. And perhaps this scene is one of the most memeable scenes of all telenovelas. It's quite easy, like if you type in escándalo, like in Giphy, like, or scandalous or anything like that, you're likely going to find something from this scene. So here's the condensed story of what happens in this scene. So what we have Soraya Montenegro, who is the individual in the bottom left-hand screaming Escuincla la babosa. So we have Soraya Montenegro, who's the main protagonist of this iconic 1990s Mexican telenovela. Let's just say that Soraya's character, well, she's not exactly the best person. Here's her story. Soraya is having a party when Nandito, her ex-lover's son, sneaks into her current stepdaughter's Alicia's room and tells her that he loves her. So that's the two young faces at the top on the left-hand side. Nandito asks to kiss Alicia after professing his love to her. And Soraya, who's still deeply in love with her ex on a way that could be, on a level that could be described as obsessive, she happens to walk into the room right when the kiss is about to happen. And she stares at Alicia and she screams, "Escuincla la babosa." The next few minutes that ensue are a huge mess, and what we observe can best be described as a very dramatic fight. Soraya basically fights everyone. She fights the nanny, she fights a random person that shows up in a full suit, she fights everyone. So this example of a scene is a very kind of, this is very telenovela. It has all the drama. And to give you a little bit of a taste of this, and again, the audio is not so important as much as it is that I would like you to get a little bit of a hint for the feel of what a telenovela is. Here's that infamous scene broken down. So she's now yelling at Alicia. So there's the nanny. Soraya is not having it. She's blaming Alicia for everything. Because again, she's in love with her ex. She's in love with her ex, and her ex is the father of Nandito. So she thinks that this like strange love triangle happens. Somehow Soraya's chance to get back with her ex are going to be thrown out the window. But she's also still married, so there's a lot here to unfold. But this is kind of considered a very, very stereotypical representation of the canon of telenovelas. So, my bad. Let me go back. So when we talk about telenovelas, something very important to understand about telenovelas is this kind of over-the-top nature of them. Jorge Gonzalez, a genetic epistemologist, that is one who studies the development of knowledge at UNAM, the National Autonomous University of Mexico, he fundamentally describes telenovelas as a social phenomena of televised melodramas that are based on the construction of a relationship of fidelity with the audience. Or put another way, telenovelas are a series of stories that create this relationship of fidelity, or that is intense loyalty with the audience, such that we want to watch the telenovelas. We must watch the telenovelas. We are compelled to watch the telenovelas. So that kind of obsessive relationship that the audience has with the telenovela is a very, very cornerstone kind of piece of the telenovela experience. You know, telenovelas are quite popular around the world. Some quick stats on Latin American telenovelas. Latin American telenovelas have been watched in more than 100 countries. About $800 million a year is used in creating telenovelas. And with Mexico alone, they produce about 3,000 hours of telenovelas each year, which costs about 250 million US dollars, which, by the way, is more or less the cost of the budget for the Hollywood film Titanic. So needless to say, telenovelas are one of the fastest growing genres in the world today, with approximately 2 billion people watching them, or, you know, somewhere around like 1/3 of the global population. So knowing that telenovelas are serialized short dramas that are uniquely defined by their almost obsessive-like love that the audience has for them, what we need to do to start understanding how we can do a deep learning implementation is not only understand what a telenovela is, but understand the arc of a telenovela. What do telenovela narratives look like? In a 2012 PBS NewsHour report focusing on the impact and power of telenovelas, Dr. Diana Rios of the University of Connecticut emphasized that emphasized the importance of cultural and familial bonds with telenovelas that are held by the viewers. As Dr. Rios says, things have to be cleaned up so the audience has satisfaction. They don't want to worry about Maria. Did she find true love? Did she find her true mother or her true father? Dr. Rio observes. So what Dr. Gonzalez actually breaks down for us in thinking about the social phenomena of what makes this intense relationship between the viewer and the telenovela, she describes that there's 3 processes that are happening. One, we have a symbolic, we are building a symbolic commonality between the social agent and the culture. 2, we're creating a believable set of worlds. And 3, we're enacting a symbolic struggle that defines basic human cultural elements in these worlds. So again, really emphasizing on making sure that these believable worlds are possible, we have to think about how do we take everyday kind of struggles that individuals may have and kind of blow them up a bit. As an example of where we may see this in other medium in the Latin American tradition, more so maybe the Mexican tradition, is in what we call corridos, which are a kind of like a format of storytelling, and the format of storytelling through song. So with telenovelas, when we think about how they have to struggle to prolong the inevitable conclusion, pulling at our heartstrings so that we continue to faithfully watch them through the end, how else can we see this in Latin American storytelling? Well, corridos, as I mentioned, is kind of an example of this in a very small format in a song. There's a famous song that is called La Fama de la Pareja by Los Tigres del Norte. And this corrido is basically telling the story of the couple Rosa and Luis. The couple traffics something very dangerous, which we are never explicitly told what it is, from Jalisco to San Diego. And their fate about what happens to Rosa is dramatically sung out through this song, with the culmination of the song telling us that the couple were successful in having crossed the border back to Jalisco with muchos millones, or that is many millions of dollars, and sus negocios prosperan, or their businesses thrive. So this idea of kind of this canon of having these like very extreme, over the top, dramatic kind of moments embedded into storytelling is something that makes storytelling quite unique if we think about the legacy and the impact of what a telenovela is. We see it not only in telenovelas, but we also see it through the expression of music. So the arc of a telenovela, if we're kind of globbing some sense together and thinking about what does it mean to authentically create a telenovela arc, let's go back to some of the things that Dr. Rios provided us. We need to have a social world that is cemented on the experience of the viewer. It needs to be believable, and we need to have a series of struggles that happen. Again, we want that emotional turmoil. So then, thinking about how we translate this back into a plot that we want our deep learning model to create, we have to think about a fixed melodramatic plot that is love lost, mothers and daughters fighting, long lost relatives, love found. We need a fixed arc with an actual tangible end, and we need a conclusion that ties up the loose ends, ideally with some kind of happy element, such as a big wedding, or, you know, becoming millionaires and having thriving businesses, as we saw in the corrido example before. So now that we've kind of diagnosed a little bit of what a telenovela is and what the arc of a telenovela ought to look like, let's actually take a look at some telenovelas. So some examples of some famous telenovelas in Espanol or in Spanish are these 3 here. From left to right, La Reina del Sur, Yo Soy Betty la Fea, and Juana la Virgen. Perhaps one of my most favorite, La Reina del Sur, is based in Mexico. Well, starts in Mexico, I should say, and is in 2011 and is actually starring Kate del Castillo as Teresa la Mexicana Mendoza at $10 million US. This is the second most expensive telenovela produced produced by Telemundo, and I'm happy to say that it is pretty awesome. You can watch it on Netflix. So we have that. We have an example of this one. Yo Soy Betty la Fea is another example of a very prominent telenovela. This is a tragic comedy, and this is actually the first telenovela to have been remade worldwide, including in such countries as Belgium, India, and Turkey. And then another really famous example of a telenovela, Juana la Virgen, is from a 2002 series in Venezuela. So while these are three really, really immensely popular telenovelas, for the sake of this talk, it's probably going to be a little bit easier to generate something in English. So in doing that, let's look at the English crossovers. So we've got Queen of the South, we've got Ugly Betty, and we've got Jane the Virgin. So the three here, if we're looking at kind of their categories, Queen of the South is a drama. It's a thriller. It's about long lost love. Basically, it summarizes the rise of Teresa, the prominent character, where she flees from Mexico and resettles in South Spain, becoming the most successful drug trafficker in the area. And also she's successful in getting revenge on the narcos who killed her boyfriend. Ugly Betty is probably something that we're quite familiar with. Again, tragic comedy, and the whole story is fixed around Betty, who basically wins everyone over with her brilliance and her charms. And it's a story about really Betty becoming one in her own and realizing she's awesome, even as she tries to compare herself to all the impossibly beautiful people in the fashion industry around her. And then Jane the Virgin is a rom-com comedy, and it has Gina Rodriguez starring as Jane, where a very religious young Latina who is a waitress in Miami somehow gets artificially inseminated when she goes to her OBGYN and ends up getting pregnant. And so it tells the impossibly wild story of what happens to her after this wild pregnancy happens. So again, notice these three have very distinct, they have strong women leads. They have very distinct kind of wild and over the top experiences, while motherhood is something that people experience, or while loss of love is something we experience, it doesn't necessarily happen like this. So now that we've explored what a telenovela is, and we've defined the arc of a telenovela, and we found some quintessential examples of telenovelas, let's talk a little bit about how we can use deep learning to do text generation. So the language of machine learning, if you think about how we've kind of seen in the earlier talk, or even borrowing from a 1950s language, when we talk about machine learning, we say the initial construct introduced to us is we say that a computer can learn without being explicitly programmed. Tom Mitchell, a professor of machine learning at Carnegie Mellon, expanded upon this definition by saying, well, it's not just that we aren't explicitly programming it, but we can set up these programs to think about providing some experience, some understanding of what is the task that program ought to accomplish. And then based on how well that computer program performs that task, we'll have a performance measurement. So we're able to say that a computer program is learning based on iteratively, ideally getting better at this task through some performance measurement. So while machine learning kind of follows that idea of having a task and experience and some kind of training to accomplish an output that we're trying to optimize and get better at doing, there's a lot in machine learning that we could talk about. So when we talk about deep learning kind of sits in the bubble of an area of research, not necessarily around tools and tech, but more so an area of research. And this movement from artificial intelligence to deep learning has continued to build upon the idea of what does it mean to achieve learning, and by what mechanism do we obtain it? With machine learning, that example of providing some ground truth, some example of how to do the task in the wild, when we have some idea of what the output should be, when we provide it some ground truth, that is what's employed in supervised learning. When we have unsupervised learning kind of implementations, we may not know what the output is, so we have to allow the algorithm to kind of infer and create categories for us. So clustering might be an example of that. For example, news clusters, if you've ever been on a news feed, and in a given day, we may not know all the news topics that are emerging. So if we have, let's say, a unsupervised implementation, figuring out what are the clusters of news topics on a given day, they might be using an unsupervised approach. And then lastly, when it comes now into deep learning, when we start moving away from what becomes new in this space is now we start talking about the agent of learning itself. We add in a neural network, the thing that actually drives and powers the learning. So an example of like what deep learning looks like, if we were to kind of provide a toy example, let's say we have a programmable flashlight, and the programmable flashlight can respond to vocal cues. The programmable flashlight maybe will hear me say like the word dark. And given that it understands the word dark, it's like, aha, I heard the word dark, so I should turn on. A deep learning implementation would not only just be able to respond to the word dark, but it would actually be able to infer meaning from other phrases. So for example, if I said, I can't see, or the light switch won't work, a deep learning implementation would actually be able to start understanding relationships between dark and like what other phrases may be similar to express darkness, where it can then turn on and illuminate and make our life a little bit easier. So the way that a deep learning model learns how to do this is through a computation method that we may call an activation function. We may call its brain, or can be better represented by a by a neutron. So with this kind of graphic here, if you're thinking about our example of the programmable flashlight, maybe initially like the input that is provided, if what the program is listening to is just my words, it may say, okay, I understand the word dark, but now I'm going to start understanding the word dark in relation to other words that you use. When we have a neural network starting to kind of think about input and how it infers meaning, for examples, if we're looking at words, what we can say is that it's not only understanding the individual word itself, but it's understanding the word in relation to other things. So in this graphic here, for example, if I were talking about milk, some other phrases that may be used to describe milk may include that it's a liquid, that it can be drunk, that it's drunk out of a glass, or that it is white in appearance. What our deep learning implementation is able to do is to derive new insights from the input provided, let's say words, assign meaning to those words, and then understand how, in relation to that input and to other input that it has previously seen, it can start to try to understand how it can start understanding new insights about how language works together. So the foundation of our learning agent then is going to be the neuron, which is based on kind of like how the human brain works. And so in thinking about the human and about the human brain, you know, we're not working with organic matter, but the architecture of a neuron is simply kind of represented like this. We have inputs. So for our example, we're talking about words. Those inputs then represent basically are some feature set that we represent as a weighted number. We then have weights, which is that some numeric value that indicates the strength of that feature. And then we pass them through a activation function, which is some nonlinear function, which adjusts the weighted sum of the inputs to basically say how, as it's trying to understand and process and perform its task, it's going to be adjusting the rate at which we're learning. That is, adjusting the weights we provide to the input to actually start modeling a linear combination of weights and inputs with some nonlinear function to actually understand and optimize what is the best optimal weight for our feature set to help us get to the ideal output. Part of how we do that is by training a neuron, which is basically just the process of iteratively updating the weights associated with the feature input vector by using a nonlinear activation function. The more that activation function mutates the input vector, that is changing the weights associated with our inputs, we say we are learning at a higher rate. Effectively, all the training process does is it approximates the underlying relationship to the data set until we find an optimal set of weights in order to do the task at hand. So for example, maybe turning on that flashlight. So at the start of this talk, I kind of threw out there this idea of deep fakes and what deep fakes do. Deep fakes are not only just the mashing of faces, but actually trying to generate speech that go along with that, some kind of believable language that would be the mashup of Jennifer Lawrence and Steve Buscemi, or in more scary examples, trying to approximate language for famous folks such as politicians. That's kind of an example of what deep learning can do for text generation. There's actually a tool here that exists that's powered by the GP2 algorithm, which in this example, which is just a screenshot showing how the GP2 algorithm created by OpenAI works, is as I start typing something, so notice I threw in just this one line of text. Lorena sat at her computer typing, scratching her head, thinking of what to write. What this is actually able to do with deep learning is then do the subsequent text generation where I've got the balance of that at the bottom where it then starts generating a narrative for me. And what's kind of wild here is it's just using, this implementation is just using words and the features of the words and the characters themselves to help start approximating and thinking of likely text to generate on the other side. So when we think about deep learning and specifically text generation as an example of deep learning, this is just basically sequence processing. So sequence processing has applications in several areas such as video processing, price modeling, and yes, text generation. There's two approaches then we have to actually doing text generation. We can feed in words or we can feed in characters to generate text. So to answer the question, how do we create something that sounds telenovela-ish? Well, let's actually use the scripts from the telenovelas themselves. And luckily, we've already gone through understanding what would be good candidates for us to look at because we spent some time trying to understand what telenovelas are. And so looking at these three, then we're able to go and pull those scripts down and use the words themselves to try to see if we can do some text generation to maybe, yes or no, generate a deep learning script. So the architecture of neural networks can differ in many factors: the number of nodes used, how many neurons are connected, the movement of information, etc. For brevity for this talk, we've selected an RNN, specifically a long short-term memory RNN, recurring neural network, as recurrent models are good, have generally speaking performed well with text generation, particularly generating text in sequence. And additionally, what's cool about using an RNN is that we're able to not only put in input and move the input of, we're not only able to put input in and have that information flow from just one node out to the output and then generate let's say a character or a word it predicts, but we're actually able to, through different architectures, move information and insights learned forward and backward, propagating to make better informed guesses about what character or what word we want to feed out on the other side. So using several layers of neural networks, we're then able, more than just the base three, which is our input, our hidden layer, which is doing that kind of activation function, adjusting the weights, and then the output, we're actually able to choose from different architectural implementations to then say we've now got a set of deep neural networks. So in making an RNN in Python, there's a few ways we can do it. We've got quite a good set of tools. We've got tools like Keras, tools like TensorFlow, and tools like PyTorch available. In fact, if you want to know a little bit more about why Python's so good in working in this space, I always suggest people check out Jake Vanderplas's 2017 keynote. But in thinking about how I kickstart things off, I always kind of start with these three framing questions. How much technical expertise is required to get started? What are your requirements? For example, how fast does it need to work? What's the size of your data set? And then also, how easy is it to work with the framework? So in thinking about each of these questions, in thinking about me, I would say I'm a beginner with deep learning. I want something that can work on a small toy project, and I'm ideally looking for something with robust kind of community support and demos. Additionally, when it comes to requirements, really the only requirements, because I am hyper-focusing on 3 telenovelas, I'm working with approximately less than 100 megabytes of data. That is only 4 seasons of Queen of the South, 4 seasons of Ugly Betty, and 5 seasons of Jane the Virgin. So we're going to be working with text data. Additionally, having something that has some intuitive debugging is always ideal. And then leading into the ease of the framework that we can use, again, sensical debugging, something that can bootstrap easily and something that doesn't require a lot of deep mathematical knowledge to get started. All of that then informs me to kind of say, well, what works with my requirements alongside what's available in these libraries. And as you can see, what kind of become ideal candidates for me look at Keras and TensorFlow specifically. What's cool about TensorFlow is it has Keras baked into it. It's got both a high and low level API, and we can make use of eager execution. And so in thinking about debugging, why eager execution is pretty good is that when you're debugging, you're actually able to debug in the order in which you write your program and iterate, unlike static execution where your program builds a structure for your neural network in advance, optimizing it so that you are using a little bit less GPU, making it a little bit easier on your machine that you're working with. If you can debug in sequence as you're learning, it's just a little bit more intuitive, I find. So TensorFlow has that add-on value. So making an RNN in Python, if we were looking at kind of like the steps that we need to consider, we would there's kind of three things we need to that we need to do. Step one, we need to transform text data into input sequences. Remember, we're going to either be using words or characters. So depending on the way we tokenize the text, that is splitting the body of text into smaller pieces, it will be guided by if you use the word or the character. And then once we have those tokenized, what we will need to do then is rescale our data into values of 0 or 1. The way that we do that, step two, is we're going to generate character hot encodings. So for words, we tokenize each word into one hot vector. For characters, we tokenize each letter into a one hot vector. Basically, hot encodings allow the model to predict the probability of each character in the vocabulary. And on the next slide, we'll kind of have an example of what that looks like. So step one, we have to transform our text data into, we have to tokenize it, and then we have to rescale it from 0 to 1 to make these vector encodings. And then once we have these vector encodings, what we need to do is we need to provide it as input for our model and then train it over some N training epochs so that we can then start using it to predict and generate text. And thinking about character encoding, if we were looking at, again, character not word encoding, let's say we had a corpus where we had the input set of A, B, C, D, E, F, G, H, I. So the length of our corpus would be 9. So what we would need to do is for each character, let's say we had the word bad, what we'd want to do is then we would want to then encode in that corpus. 0 is it the target, means false, 1 means yes. We have to generate a vector for each character relative to the length of the corpus of the number of all the unique characters in that corpus to then be able to scale our data from words into that 0 to 1 representation, which we can feed in to our algorithm. So with using Keras, as you can see, what's pretty great is that we've got our sequential model as I mentioned earlier. This is a sequential processing problem, so we're able to pull that out directly. We add in the LSTM, and then we are, so when we select our model, we use sequential, we provide the input data, again, our hot vector encoded data to the model, and then we fit the model with some number of epochs. And here we can take our text data and translate it from text into the one hot character vector. So in between, when you're doing that model fit, if you're working with your text data, you would have to do some kind of manipulation to translate it into the one hot vector data set. And then in going then to an example of what that may look like in TensorFlow, additionally, again, what we have is we're going to just be pulling in, and what we're going to be pulling in, and you'll notice here that Tensor 2.0 Plus allows you to use the Keras API, which we previously saw a little bit of a snippet of. So here we can pull in the sequential Keras model, we can add the LSTM layer, and we can add in the dense layer. And then again, we can use metrics like the Atom optimizer to help us understand how we are doing in doing text generation, to help us in solving the problem of, can we generate text that sounds telenovela-ish? So needless to say, regardless of if you're using Keras or if you're using TensorFlow, there's always going to be a fit where we're training where we will be training our model over some n epochs, again, adjusting those weights associated with our input vectors to find some optimal weight where those optimal weights help us generate words or characters rather that would appear in texts that are labeled as telenovela text. So that again, our input data is derived from the character sets provided from our telenovela scripts. We train it for some period of time to get the ideal weights, and then we can go and actually try using it in the wild. So if you are using the lower level API, you are able to use things like like using sessions and a coordinator to help you with training. But for all intents and purposes, what's good about TensorFlow is you both have that high level and low level API. And so there is actually a repository that walks through these examples in each of them, showing you as well with PyTorch how you can do that same setup of providing the input, doing the training, and then starting to actually use your model for text generation. So in getting to our culminating, creating a telenovela script with an RNN, what is possible? Here are some examples of some text generated when doing different epochs and only using a subset of our data sets. So something that I think is quite interesting here, and really as far as I've been able to get at this point, is just getting a few lines of coherent text before it starts getting a bit more murky. In looking at text generated with Jane the Virgin, if we're using only Jane the Virgin and doing 30 epochs, what we find is we get some text that is saying, is it a milagro? Milagro meaning miracle. Was I drinking? No, my God, no, I wasn't. What made you ask that? I am still me. So I thought it was interesting that, yes, you are starting to get some sequence of text that is talking about pregnancy, that is talking about like, how does someone get pregnant? The second, in using Ugly Betty only as your corpus for the input data that you train on, the text here, you see themes of like the graphics department. She works in the fashion industry at a magazine, and talking about being unhappy. So it's kind of interesting. We start seeing those themes pop up. And again, Ugly Betty is a tragic comedy. So the idea that like we're even getting words like unhappy and softer side, kind of that duality, and starting to see some of that language creep up. And looking at Queen of the South, which is that drama about Teresa Mendoza becoming the king of all narco trafficking in South Spain and North Africa. The language here we see generated is one that immediately begins with threat of violence. Do not threaten me. Do you understand me? Do you understand me? Whoa, all right. Hey, look. So when we start then kind of splicing and combining this data sets together, or in this case, using all, what's interesting is kind of the theme we get on the other side. So I'm proof that surprise happened, even if you do not believe me. Why would you? I am a woman after all. I thought that line was really, really wild. I am a woman after all, because again, these are all prominent women leads from our telenovelas that have like really extreme things happen to them. Once we start kind of combining our data sets, we start seeing different themes kind of emerging and hyper being elevated to the top. So when we think about how we can create a telenovela on par with something like Maria, La del Barrio, there's a few ways we can think about how we could start gluing some of this together. We could train a long, short-term model for just Soraya. We could train one for just Nandito. We could train another model for just the random man who walks in with a suit in the fight scene, or we could train one for the maid. So the idea is maybe we could just train models that represent characters that we know we want to have in our telenovela. Or another way we can start thinking about it is perhaps slicing and dicing our data with more granularity. So approaches for creating telenovela deep learning scripts, some ways that we can move from just having some of these lines of text that, you know, we only get a few lines, but we're not getting a whole corpus of data that is quite coherent on its own. One thing we can think about is rather than just generating one model, we can do a model per character. We can then also maybe say, let's find similar sources of inspiration for characters. So let's say I knew I wanted to generate I wanted to create a telenovela that was exploring the rise of a powerful woman in an industry that's, let's say, traditionally led by men. So maybe I could look for other telenovelas that talk about the rise of women in industry. So maybe not just focusing on industry like narco trafficking, but maybe like Betty La Fea, like Ugly Betty becomes an example. Or maybe there's another example of a telenovela that I can pull in that can help me provide inspiration for this character model that I'm building. Additionally, the idea then of just creating these models for individual characters, we can also then think about, you know, it's not just that we create an individual character, but we're perhaps creating a strong woman lead in a tragic comedy. So the way that we can start kind of weaving these models together, we have to start getting kind of creative in how we have them play off of one another. So generating short-term models for telenovelas for each type of melodrama could also be another angle that we take. So maybe we have a model that does some general filler text about long lost love or amnesia or all of the amnesia. There's quite a few ways we can think about crafting and building our plot together. So needless to say, text generation is hard. So creating the learned plot, while it may arguably be possible, I would say without coherent narratives or emotionally compelling characters, we continue to miss the mark. So how can we do better? I'm going to say that one of the things that would be really great is getting more data. So not a unique problem here, but in looking at varying data quality, I actually myself have been the one transcribing these scripts because there's not really a place you can go and like buy them on the internet. So like one way, like in looking at some of these texts, like you'll notice that some telenovelas, for example, in Jane the Virgin, you have like this use of a narrator, whereas in others you may not. Or if you are using pre-existing data sets, looking at what information you're given versus not. So like the idea of when you read a play script, you're sometimes given stage directions of how people walk in or what's happening in the background. If you aren't building your own data set and you're using pre-existing ones, be mindful of what's in there. How are you going to standardize and make them similar across the board? If you are building your own, what are you capturing in them? Is just text enough to help us think about the generation of, is text data itself enough to help us in creating a plot or creating a script for a telenovela? So in thinking about more ways we can move the needle, I'll just say that the ones that are currently in flight for me, I am working on Rosalinda, Muchachitas, Dos Mujeres, Un Camino. And I am actually looking for people who want to like help me build my corpus of data with telenovela scripts. So if that is at all of interest, I do have that actually on GitHub, where I'm hosting my telenovela scripts. So that's I think going to be the first step because it does take a while to build all these. I actually did have to do a good amount of watching all of those telenovelas for my initial data set. And, you know, at the end of the day, one of the things I would like to encourage you to remember is that even the world's most advanced machine learning platforms can be tripped up by such things like a chihuahua versus a muffin. So we continue to see today that a toddler can be out deep learning and when it figures out what's food and what's Fido. But I would encourage us all to think about how we can continue to bring creative computation into the world with deep learning and see what kind of good projects we can get on the other side. So for continued learnings and things, I've thrown some examples here of articles and blogs you can read and videos and courses you can participate in. And of course, if you're at all interested in helping me continue my journey of creating a telenovela, I definitely would love people to help work on this really kind of wacky problem with. And that is going to be my talk in a nutshell. So I appreciate you all. I know we went a little bit over, but that's kind of where we're at with telenovelas and deep learning.
Awesome. Thanks so much, Lorena. That was a very, very fun presentation. Had a lot of fun. I know you're not going to be taking questions, but do you have any call to actions for a community? I know you mentioned something at the beginning of your presentation.
Yeah. So, well, one, I would honestly love people to like work on like doing this. Like if you know places where I can get like telenovela scripts, like that would be awesome. But actually, in all seriousness, what some of the things I think would be really great for us as a community to be mindful of the Okay, I'm not sure if you can still hear me, but it looks like
I can still hear you. Your video's frozen, but we can hear you.
Registering on python.org to be a member so that folks can register for upcoming elections and can participate in the broader Python ecosystem would be a great thing to do. And also, too, I would love if folks would join us in the Chippy Slack in talking about bias in tech. I know we've got that channel set up, and it would be great to kind of continue that conversation.
Yeah, we'll definitely add a link to that at the end of tonight. But thanks so much for your time. This was a fun presentation.
Thank you. Well, at least it froze just at the end.
No, it was great. Thanks so much, and we'll see you around.
Great, thank you.